So hello friends, hope everyone is doing great. So today we are going to talk about the next topic of geometry, which is circle. We'll cover primarily basic concepts of the circle, some of the formulae and some properties of circle which are related to lines and angles. So first we'll define what is circle. So circle is set of points in a 2D plane which are at same distance from a fixed point. So I'll just draw a circle for reference. So this is my circle. So circle is made of these points. If you see this periphery of the circle, it is made up of points in 2D plane. And if I consider the fixed point here, C, it is a fixed point, and if I consider each of these points in this set, it is at the same distance from this fixed point C. So this point C, I call this as the center of circle. And if I draw a line from this fixed point to this set of points in this plane, so I'll call this as a radius. I'll just note that as a R. So this is the radius of the circle. Similarly, if I draw a line from this periphery and it is passing through the center of the circle, I'll call this as a diameter. So this part is a diameter. I'll just note it as a D. So the first formula is the diameter is always 2 times the radius. So D is equal to 2 into R. Correct? So if I consider this circle, if I have to find the length of this periphery or perimeter of this circle, I call that as circumference. So if I consider this point, if I have to find out this distance of the circle, I'll call that as circumference. So how can I compute that? So circumference of the circle is equal to 2 into pi into R, where R is radius of circle. Pi is generally we consider 3.14 while solving questions, and we multiply that with 2. So this is how we calculate circumference of the circle. So if we have to compute the area of the circle, this is in 2D, this is the 2D shape. So if I have to consider this area, I'll just mark that with cross lines. So if I have to consider the area, how can I compute the area? So there is a formula to compute area of the circle. Area is equal to pi into R square. So where R is radius of circle, pi we can consider 3.14. So this is the formula to compute area. So now we'll look two more terms which are related to circle. One is arc and the other one is sector. So how can I define arc? So I'll just consider the circumference or periphery of the circle. I'll just mark 2 points here. One point A, the other point is B. So if I consider this part of the circumference AB, I consider this as arc of the circle. It is a part of this periphery or circumference. If I have to define sector, so if I draw two radii from point C, AC and CB, the inscribed area, this one ACB, this area I'll define it as sector of the circle. So there are two more formulas which are related to arc and sector. So we know this arc is a part of circumference, right? So if I have to compute the length of arc, so I know this entire circle is 360 degree. So if I draw an angle from C, it is 360 degree. So the angle which is inscribed here by this specific arc AB, I'll just call it as theta. So if I have to compute the length of the arc, what I have to do? I have to put the formula theta upon 360 into 2 pi r. 2 pi r is total circumference and AB is a part of the circumference. So this is how we can compute the length of this arc AB. Similarly, we can compute the area of the sector. So area of the sector, how can I compute area of sector is equal to same theta by 360, and we can consider area of total circle, which is pi r square. correct? So this is length of arc and this is area of sector. Okay, so now we have seen the basic concepts and formulae. Now we'll move to the properties of circle which are related to lines and angles. So first we'll start with lines. So lines in a circle, we'll consider primarily two lines. One is chord and the other one is tangent. So chord, how can I define it? So chord is basically a line segment whose endpoints are on the periphery of the circle. So I'll just draw a circle for reference here. This is my circle. I'll just draw 2 points of on the periphery, point A and point B. So if I draw a line from here, point AB. So this is my line segment, correct? AB. So I'll just call this as a chord. If I draw a center of the circle here, and if I draw chord which is passing through the center, what will I call it? I'll call it as a diameter. And diameter is the largest chord of the circle. There is one property related to chord. So if I draw a perpendicular line from center of the circle, this chord, this line always bisects this chord. So if I consider point E here, intersection point. So in this case, AE will be equal to EB because it has bisected this chord AB, correct? So now I'll move to tangent. So how can I define tangent? Tangent is a line which touches the circle at one point, circle boundary at one point. I'll just draw a circle here, and at a boundary I'll consider my intersection point with the line. This is the line and the intersection point is A, and here is my center of the circle. So if I connect this point C and A, this will be my radius, correct? Because I am drawing a line from my center to the periphery of the circle. So this will be my radius, and this radius will be always perpendicular with the tangent. This is another property of tangent. Now we have seen property of circle with respect to lines. Now we'll move to some of the properties which are related to angles. So in angles, we'll primarily see two major angles. First one is inscribed angle, and the second one is central angle. So first, if I talk about inscribed angle, so how do I define the inscribed angle? So inscribed angle is angle formed by two chords which are intersecting at periphery of the circle. So I'll just draw a circle for reference here, and we'll consider two chords, chord AB and chord BC. So are these two chords correct? They are intersecting at a point on the periphery of circle, correct? So here this angle which is made by this two intersecting chords, I call that as inscribed angle. So if you see here, this point AC, it is making an arc here, right? It is part of circumference. So this arc is making this angle at the boundary of the circle, correct? So I call angle ABC as an inscribed angle of this arc AC. And there is a very important property of inscribed angle. So if I consider this arc AC, and if I consider any point on periphery, if I draw another two chords with point D here, so this angle ADC is always equal to angle ABC. So basically the property tells us if an arc is having any inscribed angle from the arc in a circle, they are equal. So in this case, angle ADC should be equal to angle ABC. So this is the first property of inscribed angle. There is one more property. If I draw a circle here, with this as center, and if I draw a diameter of the circle, if I draw one inscribed angle of diameter, correct, here, and name it as A, B, D, correct. So this angle is inscribed by the diameter, so this angle is always 90 degree. So even if I consider another point here, if I draw this line, if I consider this point as G, so in this case this angle also will be 90 degrees. So angle inscribed by the diameter is always 90 degrees. So here angle A, B, D equal to angle A, G, D equal to 90 degrees. So now we'll move to the next angle, which is central angle. So how do I define central angle? Central angle is angle made by the arc at center of the circle. So if I draw another circle here for reference, with C as its center, if I consider this arc here, AB arc, if I draw two radii here, AC and BC, so this angle made by this arc at center, I called it as the central angle. There is one more property with respect to central angle. So with this same arc AB, if I draw inscribed angle here to this circle, so let's say this is my inscribed angle with point D here, correct. So this inscribed angle is always half of the central angle of the same arc. So the property tells us the central angle made by the arc is always 2 times the inscribed angle made by the same arc. So in this case, angle ACB, which is central angle of this arc, it is 2 times the inscribed angle, angle ADB.